All right. Welcome to Math Chem and Chris. So we have this question here. It says the first 3 terms of a geometric sequence are also the first 11th and 16th terms of an arithmetic sequence. The terms of the geometric sequence are all different. The sum to infinity of the geometric sequence is 18. So we want to find the common ratio of the geometric sequence, and then we'll find the common difference of the arithmetic sequence. So let's start. Okay, so the first 3 terms of a geometric sequence will be given as A, where A is the first term, AR, where R is a common ratio, and AR squared. So this question is for those that have started doing the sequence and series. You know something about sequence and series, but maybe these kind of questions are difficult to you. So I don't expect to go all the way down to explain the basics up, right? So this is for those of us that have started doing it and we understand the basics of sequence and series. So I have A, AR, and AR squared as the first 3 terms of my geometric series. Now let me use U1, U11, and U16 as the terms in the arithmetic sequence. So U1 is the first term, U11 is the 11th term, and U16 is the 16th term. Right. For the purposes of really understanding what we are doing, I want to put these terms on a number line. So tell me what you think. If U1 is here, where do you think U11 will be? So U11 is 10 steps away from U1. So let's assume that U11 will be somewhere here, right? And then U16 would be somewhere here, right? If I'm to arrange the numbers on a number line. So that is to also tell us something. That from U1 to U16, I moved 10 steps. And from U1 to U11, I moved 10 steps. But from U11 to U16, I moved 5 steps. What does this tell us? It tells us that the distance between U11 and U1 is twice the distance between U11 and U16. Because from U1 to U11 is 10 steps. From U11 to U16 is 5 steps. So it tells us, so since 10 is a double of 5, it tells us that the distance between U1 to U11 is 2 times the distance between U11 and U16. So we can draw a certain conclusion. We can say that U11 minus U1 will be equal to 2 times U16 minus U11. Right? Because we had said that the distance between U11 to U1 is 2 times the distance between U11 to U16. Does this make sense? All right. But now let's come back to this. Do you remember we said from the question that the first 3 terms of the geometric sequence are also, so this is the part of the question that highlighted that, are also the first 11th also the first 11th and 16th terms of the arithmetic sequence. So this would imply that U1 would be A, U11 is also the second term of the geometric sequence. So U11 will be AR, and U16 would be AR squared. Does this make sense? Good. So what I'm going to do now is that I'm going to substitute U1, U11, and U16 into the equation. So this gives me U11 is AR minus A equals 2 into brackets AR squared, because AR squared represents U16, minus U11 is AR. Make sense? So let's move on. Then I would now have AR minus A equals 2AR squared minus 2AR. What do we see? It's like we are working in two variables. It makes it difficult. So if there is a way we can get rid of one variable, it makes our work easier. And voila, there is it. We can factorize, or we can cancel through or divide through by A, so that all the A's will cancel, because I'm seeing that every term there has an A. So I divide here by A, that by A, that by A, and that also by A. And then I can now cancel them. A cancels A cancels A cancels A, and A cancels A. So what am I going to be left with? Let me write it here. So at this point I have R. No. Let me put it here. So at this point I have R because the A's have cancelled out. And from this point, A over A would give me 1. So I have R minus 1 equals 2R squared minus A's have cancelled, so 2R. Make sense? So I now want to work with these ones. I want to bring the R minus 1 to the other side because I don't want the R squared term to be negative. So I'll have 2R squared minus 2R. Now when this R comes to the other side, it's positive here, so it becomes negative. So minus R plus 1 equals 0. So this then gives me, I was supposed to write it into one quadratic equation, but I don't want to do that yet because my goal is not to form a quadratic equation from it. My goal is to find the value of R. So what I'm going to do now is that I'm going to put these first two terms into one bracket. So I have 2R squared minus 2R minus R minus 1. The smart ones here would know how the positive became a minus here, because the moment I put the bracket, it means that the negative outside there will affect everything here. So if the negative affects the negative, it takes us back to positive, right? So it's time for factorization. 2R comes out. I have R minus 1, then minus 1 out, because there was always a 1 in front, you know. Then I have R minus 1 equals 0. So this gives me 2R minus 1 and R minus 1 equals 0, right? So we can equate 2R minus 1 to 0 and R minus 1 to 0, so that this will give me R equals half, and this would give me R equals 1. Okay. One of these two questions is right, and the other would not be accepted for the purposes of this question. How do we know that? How do we know which one is going to be accepted and which one will not be accepted? Let's come back to the question. Some part of the question tells us that the sum to infinity of the geometric sequence is 18. This tells me, or this gives me, two ways to find out which one of the two solutions of R is right or wrong. if the sum to infinity of the geometric sequence is 18, I can write sum to infinity equals 18, and the formula for finding the sum to infinity is a over 1 minus r. So this implies that 18 is equal to a over 1 minus r. But we have found two values for r. One is the one of them is r equals 1, and the other would be r equals half. Which one of them would be thrown away or would not be accepted for the purposes of this equation? Like I said earlier, there are two cases that gives us this idea. The first one that I'm going to talk about, which will be very obvious to some of you, is that when I put r equals 1 into the equation, so let me do that here. So if I put r equals 1 into the equation, it gives me 18 equals a over 1 minus 1, and that is 18 equals a over 0. So you see, I have the denominator to be 0, and so it makes it undefined. So that is one reason why r equals 1 cannot be there. Right. But why should r equals half be there? This is the reason. In a geometric series, there are two kinds of geometric series. We have the divergent geometric series and the convergent geometric series. A geometric series is either diverging or is either converging. When a geometric series is converging, the series approaches 0. And so if the series approaches 0, it is then possible for us to find the sum to infinity, because the subsequent terms become smaller and smaller and smaller and smaller, such that they become almost negligible. And so if a series is converging, it's possible for us to find the sum to infinity. It's possible for us to find a value that represents the sum to infinity. But if a series is diverging, it approaches infinity, and so the sum to infinity will still be infinity. And so when a series is diverging, it is not possible for you to find the sum to infinity. Right? So when a series is converging, we can find the sum to infinity. But when it is diverging, we cannot find the sum to infinity. But how do we tell whether a series is diverging or converging? Because in this case, since we have been able to find the sum to infinity, then it means that the series is converging and not diverging. So if the series is converging, what does it say about its common ratio r? It says one thing. When a series is diverging, the common ratio r is greater than 1. But when a series is diverging, the common ratio r is lesser than 1, but also greater than 0. Let me be quick to add that. So for this series to have a sum to infinity, it means that it is converging. And the fact that this series is converging, it means that the common ratio should be should be lesser than 1. It shouldn't even be equal to 1. It should be lesser than 1. So of the two options we have here, r equals half and r equals 1, we will go for r equals half, because half is less than 1. And if half is less than 1, it means that that's what made it possible for us to find our sum to infinity. Okay. So then I would go for r to be half. And so this would imply that the sum to infinity, which is given by a over 1 minus r, would be 18 equals a over 1 minus half, which would also be 18 equals a over half. Right. Let's not overcomplicate this. we want to find the value for a. This looks like 9. Let me erase that and write it well. We want to find the value of a. And so if we want to find the value of a, we will simply multiply both sides by half. So that half cancels half in this case. But then, wait, let me write that well for us. And in this case, half of 18 would be 9, right? Those of us that already know, half of 18 is 9. Or 2 would cancel 18 9 times. So I would now have 1 times 9 is 9 equals a. So I have now found the value of my a. Let me write this well. So a equals 9. Let me separate them because like the two look kind of alike. Great. If my a is 9 and my r is half, what then will be the progression of my GP? Because the progression of the GP were a, AR, and AR squared. So if my a is 9, it will be 9 times half, because r is half, and 9 times half squared. But say the question did not ask us to find the progression. So why are you doing that? I just wanted us to do it so that it will make sense, right? Good. So the first term is 9. The second term will be 4.5. 9 times half will be, yes, it will be 4.5. That is like 9 on 2. Right, this is it. So this is the second term of the GP. But mind you, the second term of the GP is the 11th term of the AP. We said that up here. Right, so the second term, which is AR, is the 11th term of the GP. So this would imply that U11, which is the 11th term, is equal to 9 on 2. And this would also imply that U11 will be A plus 10D. Like I said earlier, this particular question or problem is for those of us that know about sequence and series. I'll do a short video on introduction to sequence and series. So if you're not getting what is going on here, you can go and watch the shorter videos. But this is for those of us that have started doing sequence and series, and so we know what is going on right here. So the 11th term is A plus 10D, and that would be equal to 9 on 2. But my A is 9, so this gives me 9 plus 10D equals 9 on 2. Solving further, I would have 10D is equal to, why do I keep doing 9 on 2? So 9 on 2 is 4.5. So let's make it 4.5 minus 9. So 10D would be equal to negative 4.5. And D then will be equal to negative 4.5 over 10. So the common difference will be equal to negative 0.45. Right? Great. So question solved. We have found the common difference of the question to be negative 0.45. And we have also found the common ratio to be R equals half. This is Math Chem.